Hello, everyone. It is Wednesday, which means it's time for another Chem Help ASAP live stream. So, last week we talked about naming ionic compounds. So, this week we are going to talk about naming covalent compounds. Now, sometimes you will hear those also called molecular compounds. So, covalent, molecular, in terms of naming with prefixes, this is going to be the same thing. So, we're going to start by first identifying what is an ionic compound versus a covalent compound, so you know which set of rules to use. And then we're going to do some practicing with not only taking a molecular formula and writing a name, but also taking a name and writing a molecular formula. If you have any questions, please feel free to put them in the chat. I will be checking that regularly. So let's go ahead and get started. Okay, no, I do not want to exit full screen. So the first thing I want to talk about is how to identify if a compound is ionic or covalent. Again, so you know which set of rules to use for naming them. So the important thing to remember is ionic bonding is different from covalent bonding. So when you have an ionic bond, what you've got is you've got an exchange of electrons. So you've got the cation, which is going to donate electrons, and the anion, which is going to accept electrons. Now, when you form an ionic bond, you're forming a bond between a metal and a nonmetal, or oftentimes you'll have a metal and a polyatomic ion. A big hint, if you have an ionic compound, is if there is a polyatomic ion as part of the compound, either as a cation, that would be ammonium, or as an anion, then you are going to have an ionic compound. You're going to want to use ionic rules, not the rules we're going to go over today. So you can see on the periodic table, your metals are basically all of these guys. Oh, sorry, your Fs are part of metals as well. So metals encompasses a large portion of the periodic table, but we usually think of them as being on the left-hand side, or kind of central to left-hand side of the periodic table. Obviously, hydrogen is an exception to this. Now, when you have a covalent bond, it's a completely different kind of bond. You don't have the exchange of electrons, you have sharing of electrons. So you don't form a cation and an anion because you don't have one element that wants to give up electrons and another element that wants to accept electrons. I think of covalent bonding as taking all the valence electrons, putting them in a pot, and everybody shares them. Now, covalent bonding is also going to happen between nonmetals. Now, your nonmetals are going to be generally over on the right-hand side of the periodic table, and it's going to be, again, a bond between a nonmetal and a nonmetal. So as soon as you have a metal, you're going to have an ionic bond. But if you have two nonmetals that are bonded, then this is going to be a covalent bond. The other thing I want to put in as a bit of a disclaimer is this is naming simple covalent bonding. So this is not getting into naming when you talk about organic compounds. That's a completely different set of naming rules. This is not what we're talking about here. These are simple binary compounds, meaning it's just two elements that are bonding, but you might have different numbers of atoms of those elements. The other thing I want to point out with our examples, while some of our examples will be real world examples, a lot of these examples here are completely made up. They're just made so we can practice all of the rules. So a lot of these compounds will look a little bit odd. That's because they do not exist in the real world, but we can still practice our naming rules using these compounds. Okay, if there are no questions, it looks like we're good to go. Let's get into naming covalent molecules. All right, so as usual, we're going to set up some rules so we know what we're dealing with. So when we're naming covalent compounds, and again, these are all binary. They're just two elements, even though there might be different numbers of atoms of the element. They're still just two different types of elements. So we are going to name the first element with its elemental name. So we're not going to change the name of the first element. Again, this is not a cation. This is just the first element that's written. We are going to name just with its elemental name. When we get to the second element, and there are only two, we will change the ending to IDE. So this is similar to the ionic compounds. When you have binary ionic, you will also have the IDE ending. But again, we're changing things just a little bit because we are going to use prefixes to specify how many atoms of each element in the molecular formula. So if you remember ionic compounds, we did not specify how many atoms were in each because we didn't need to, since we could predict what the charge was on either the cation or the anion. But in this case, because we are sharing electrons, and again, some of these are not real world examples, we need to specify how many of each element we have. Now, when we use the prefixes, you can see I've got all of my prefixes down here. So we've got 1 through 5 in the first part and 6 through 10. And we won't go past 10, actually. We probably didn't even need to go all the way to 10, but that's beside the point. When the first element is by itself and you only have one atom, we are going to drop the mono. And again, we'll see examples of this. And the second exception is we're going to drop the last vowel on a prefix if the element also begins with a vowel. And the kind of classic example of this is we're going to talk about things being monoxide and not monooxide. So you can see I simplified, there's only one O instead of two O's. So that's just to make it a little bit easier to say monoxide instead of monooxide. Okay, but really I think the best way to do this is to jump into some examples and show the application of all of these rules. So let's go ahead and do that. So we'll start with a classic. Now, you already know the name of this compound, even if you didn't know all of the rules. But this is a great one to remember how to apply the rules, and it's also a good one for the exceptions. So my first element is carbon. And how many carbon atoms do I have? Well, I only have one. So I am going to name it carbon. Let me make sure I'm not, yes. But notice I don't put the mono in front. Why don't I put the mono in front? There's only one carbon. Shouldn't we use a prefix? This is the exception. Remember, we drop the mono if it is the first element written. So carbon is the first element written. There is only one. We drop the mono on it. So it's just carbon. Now we're going to go to the second element. Now for the second element, we're going to change the ending to IDE per our rule number 2. So this is going to be oxide. And now we're going to use the prefix to specify how many. How many oxygens do we have? I have 2. If I come down here to my list, or sorry, my table, 2 elements gives it a di. So it's going to be dioxide. Now, this is one because those vowels don't repeat. We don't simplify it like monooxide to monoxide. This is dioxide, as you probably already knew. So this is carbon dioxide. This is a great example to use if you're taking a test and maybe you're a little bit, panicky, or the adrenaline's going and you can't remember the rules. Go to carbon dioxide because it not only tells you name the first with the elemental and the second you change to IDE, it also tells you to use your prefixes, and it also reminds you to drop the mono if for the first element you only have one. So it's really a great example to use to just help remind yourself of the rules and also the exception of the dropping the mono. Okay. That is our first, that is our known. Let's go on to our second example. So we have SO3. And of course, we want to use this using our rules. So my first element is sulfur. I only have one, so I'm going to drop the mono on that because it is my first element. So it is simply going to be, sulfur. I forgot my L. Let me get that in. Just named with the elemental name. Now, for my second element, it's oxygen again, which is oxide. And now I need to use my prefix. This time I'm specifying 3. So number of atoms, 3, which means my prefix is tri. So this is trioxide. Again, the vowels don't repeat, so we don't simplify. All right, let's make sure there are no questions. Let's go on to my next one, PCl5. Again, I'm going to name my first element just with the elemental name. I'm dropping the mono because it is the first element, so this is simply phosphorus. Now, my second element is chlorine. I'm going to change the ending to IDE. So it's going to be chloride. Now I need a prefix. I need a prefix for 5, which I go to my table 5. The prefix is penta. and so it goes right in front of the chloride. So that is phosphorus pentachloride. My next one. All right, so I've got sulfur first again. There's only one, so I drop the mono. I've got fluorine as my second element. Again, I change the ending to IDE, so this is fluoride. And now I need a prefix to specify that I have 6 of those fluorine atoms. So going to my table, 6 atoms is a hexa prefix. Sulfur hexafluoride. Okay, so hopefully these are coming a little bit easier. We're going to still keep practicing examples. It takes a little while before those rules to really set in. Okay, again, I've got phosphorus. This time I have 3, so I need to specify that. So if I go to my table, 3 atoms, prefix is tri. So this is triphosphorus. My second element is chlorine. Change the ending to IDE. This is chloride. I have 5 of them, so let me go to my prefix 5. The prefix is penta. Now, the nice thing about the triphosphorus pentachloride and also the hexafluoride is we don't have to worry about vowels. So you can see how, again, we're not doing any math like we did with the ionic compounds. You're literally specifying how many atoms of each element you have. Okay, let's do a couple more examples of these, and then we'll switch and we'll do this backwards. Okay, again, I'm leaving my rules for my naming and also my table with my prefixes in it. Okay, so my first compound, N2O2. Can we see that one okay? Yeah, we can see that one okay. So my first element is nitrogen. I just name it with the elemental name. So this is nitrogen. How many do I have? I have 2. So going to my table, 2 atoms means I use the di prefix. Okay, now my second element is oxygen. Again, change the ending to IDE. This is oxide. How many do I have? I have 2 again. So again, that is dioxide. So this is dinitrogen dioxide. Sorry, I left quite a bit of space there, but that's fine. There should be a space between naming the first element and naming the second element. It's not all smashed together. Okay, so for my next one, I've got fluorine as my first element. So we'll go fluorine. How many do I have? I have 3. So again, if I go to my table, 3 atoms is a tri prefix. I'm going to have to kind of put that in like so. My second element is phosphorus. I need to change the ending to IDE, so that is phosphide. How many do I have? I have 6, so going to my table, the prefix for 6 is hexa. Sorry, that is a little bit smashed. That is hexa. So this is trifluorine hexaphosphide. Now, what can be confusing about this is we're very often used to seeing fluorine as the second element, or maybe an ionic compound, seeing it as the anion. But this is a covalent compound, and we always name the first element with the elemental name. So you must resist that urge to name it fluoride. It is not fluoride. It is fluorine in this case. But you can see for SF2, now we have fluorine as the second element. We will change the ending to IDE. So it's all about being very systematic and following the rules and naming the first element always with the elemental name, even if you feel like you're used to seeing it named differently. Okay, so my first element is sulfur. There's only one because it is the first element. I will drop the mono, so I won't write the mono. My next element is fluorine, but because it's my second element, now I will change the ending to IDE. How many fluorine atoms do I have? I have 2. So again, 2 atoms gives me a di prefix. So this is sulfur difluoride. Okay, now we get into some really weird ones. Again, these do not exist in the real world. We are just practicing using our rules. Okay, so this one is NS9. So nitrogen is my first element, so I simply name it nitrogen. There's only one, but because it is my first element, I'm going to drop the mono. My second element is sulfur. So you see in this example, sulfur was my first element. Now it's my second element, which means I need to change the ending to IDE. So this is sulfide. How many do I have? I have 9. Again, does not exist in real world, but that's okay. 9 gives me a prefix of nana. I can still name it. It's totally fine. Okay, so that is nitrogen nanosulfide. Now for our last example where we're going to take our molecular formula and get to our name. Here again is fluorine written as the first element, which means I need to leave it as fluorine. How many do I have? I have 7. Again, not a real example. Okay, so that is hepta. So we have heptafluorine. My second element is bromine. Again, I'm going to change this ending to IDE. So this is bromide. How many do I have? I have 10. The prefix for 10 is deca. So this imaginary compound is heptafluorine decabromide. So you can see how we can apply the names even with completely made up and not possible in the real world compounds. It's just all about being systematic and following the rules. Okay, let's see. No questions. So let's change gears. And now we're going to go from the name back to the molecular formula. Again, this is much easier than doing ionic because we don't have to do any math and figure out what charges are. The name is going to tell us how many of each atom we have. All right, so I have dinitrogen trioxide. We're going to take this first element, then second element. My first element is dinitrogen. Well, nitrogen is written with an N. It is dinitrogen, which if I go to my prefixes, you can see di means 2, so that is N2. Trioxide, oxide comes from oxygen. Tri is a prefix for 3 atoms. So that is N2O3. Okay, let's go to my next one. Carbon monoxide, which you already know. But again, we're going to apply our rules. So carbon, just carbon, is written as C. Now, how many do we have? Because I don't have a prefix to specify. Well, remember, when it's the first element and you only have 1, you drop the mono. So it's just C. We don't have any more than 1. Oxide is oxygen. How many do I have? I have mono. And remember, this one's simplified to monoxide instead of monooxide. So I just have 1 oxygen. So carbon monoxide is CO. Again, that's a good one also to help remember your rules as well. So let's go on to my next example. Tetranitrogen hexabromide. Okay, we're getting into fantasy compounds now. All right, tetranitrogen. Nitrogen, N. Tetra is my prefix. Finding that prefix in here. Here is tetra. That means I have 4. Okay, my second element, bromide. That comes from bromine. That is Br. How many do I have? I have hexa. So again, find hexa. Here's hexa. That means I have 6. So that is N4Br6. Okay, keeping on moving. I have dinitrogen tetroxide. All right, so nitrogen is N. Di, you can see di here means I have 2. Tetroxide, oxide, is O for oxygen. And again, this is a simplified one. So it came from tetra. Here you can see tetra, and that is 4. So that one can be a little bit tricky because we simplified the vowels there. But again, you're not going to find the only other prefix that starts with a T is tri, and this is definitely not tri, so that can help you out there. Okay, let's go to my last one on this page. Trisulfur heptachloride. Sulfur is S. Tri, here's tri, means 3. Heptachloride. Chloride is Cl. My prefix is hepta, so finding hepta, here is hepta. That means I have 7. So that is SCl7. Okay, let's just do a few more here. Okay, phosphorus trichloride. So phosphorus, of course, is just P. How many do I have? I don't have a prefix. That's because it's the first element. That means I drop the mono, which means I just have one phosphorus. Trichloride, chloride is Cl. Tri is right here. It means I have 3. Okay. Sulfur hexafluoride. Sulfur, of course, is S. I only have 1 because I've dropped the mono. Hexafluoride. Fluoride comes from fluorine, so there's F. Hexa, finding hexa here is 6. So that is SF6. Trisulfur monophosphide. All right. So sulfur again, but this time I have the prefix tri. So if I find tri here, that is 3. Monophosphide. Okay, phosphide comes from phosphorus, which is P. And mono, you can see here, is 1. So I leave it alone. Again, you can write the 1, but we generally don't write the 1. So that is simply S3P. Okay, carbon disulfide. Carbon is C. Again, I have clearly dropped the mono because it is the first element, so I only have 1 carbon atom. Disulfide, sulfide is S. Di, my prefixes, means I have 2 atoms. That is CS2. Okay, my last example, dicarbon trinitride. Carbon is C. Di is 2. Trinitride. Nitride comes from nitrogen. Tri, you can see right here, is 3. And that is it for all of our examples. So you can see that naming covalent compounds is really a lot easier than naming your ionic compounds. I think the trickiest part is to identify what kind of compound you have. Do you have an ionic compound? Again, you're looking at a metal bonded to a nonmetal or a polyatomic ion. Or do you have a nonmetal bonded to a nonmetal? Again, remember those nonmetals are more on the upper right-hand side of the periodic table. Then you want to make sure you're using your prefixes and you're using your rules for covalent compounds. And that is really it for tonight. This was pretty simple. As always, please let me know what other topics you would like to see, what other topics you need help with. I am happy to do any chemistry topics. Just let me know. You can either send me an email or you can send me a message of Facebook. You can also leave a comment on this live stream and let me know what you're interested in, what you're struggling with in class. Thanks so much for joining us, and I'll see you next week. Bye.